So our first speaker is Brock Bernstein. You're going to give the PowerPoint, yeah. So Brock's going to give us our first development of multi-indicator assessment, so it's sort of the overall kind of big picture of what we have to deal with. And with that, I'll bring Brock up.
Thanks, Eric. So the answer, obviously, to all the problems Eric identified is just to pick one indicator, and then all that stuff goes away, right? So I put this together with Lillian Bisset at the San Diego Regional Water Board, and between the two of us, you know, we have a fair amount of experience in trying to wrestle with some of the things that Eric talked about. And so Eric asked me to try and do a little more thorough stage setting for the rest of the session by looking at a little more depth at some of the kinds of issues that people struggle with. And then I've identified or I've illustrated 4 other programs that have wrestled with this kind of stuff in different ways and have come to different kinds of approaches, and they sort of represent the range of answers, a range of solutions that people have tried to apply to this. So the questions that Eric asked, they all seem very simple. They're pretty declarative, or not declarative, but they're simple English sentences. They're simple questions. It seems like the answers should be like, how healthy are the streams? Well, they're pretty healthy, or are they getting better or worse? Yes or no? The answers seem pretty simple, but they're not. Because the systems are very complex. This is just, you'll recognize this, it's a conceptual model for impacts on a stream system and all the different pieces that affect all the different indicators, and this probably doesn't even show half of the interaction effects, especially second order interaction effects that really drive some of these systems and create some of the impacts and explain how some of the stressors work. So the systems are pretty complex. So what do we do in response to that? Well, one of the things that we've done in the past is we measure what's really easy. And so for those of you who can't read the cartoon, this is the famous cartoon from Mutt and Jeff. The guy's looking for something under the light post. He's looking for his car keys. And the cop asks, well, why are you looking here? And where did you drop them? I dropped them over there. Well, why are you looking here? Because this is where the light is. And so it's a classic answer or explanation for why you're doing something that doesn't really answer your question. Well, it's because it's what I can do, and it's where the tools are and the light is. So what we've done in the past is look at single chemicals or single indicators. We've asked simple kinds of questions. We've looked at trends in terms of whether they're just going up or down. We haven't looked for more sophisticated patterns, either spatially or temporally. And we've tried to stay away from process metrics because when you start getting involved in processes, things get pretty messy. And so it's a combination of you know, our management and regulatory systems needing simple answers in order to make decisions, and the fact that it takes time for the monitoring and the statistical and the analysis tools to evolve and for the computer systems to evolve. Dave Paradis and I were just reminiscing about that, shows how old we are, about the good old days when if you wanted to run a computer program, you actually had to take your card deck of data, real cards. Those of you who don't know what those are, they were cardboard kind of things that had 80 columns. And you loaded your computer program, the actual program in the computer, and it compiled it, and then you loaded your card deck. And if you had forgotten to number your cards, and you screwed up and tripped over something on the way to the card reader, and your cards fell on the floor, you were really screwed. So it takes a while for the capabilities to advance to where we can get beyond these kinds of simple questions and answers. So we do simple things, or we measure lots of indicators. So this is part of the Bering Sea report card. The North Pacific Fisheries Management Council about 10 years ago decided that they really needed to include more ecosystem factors in their fishery stock assessment. And so these are things like the biomass of different predators or different foragers. They're the diet of different kind of bird species like tufted puffins. And so they have fairly long time series, and they were trying to, over here talk about the means over time and the trends over time, and so the different symbols here in these columns tell you whether it's above or below the mean and whether the trend is increasing or decreasing by more than a standard deviation. And I mean, it's a tremendous effort to even measure and then organize all this data so it can be presented in one place. So it's a tremendous sort of success in that regard, but the extent to which they've gotten, at least in terms of reporting this, is reporting a whole series of indicators and letting you then do the synthesis in your head. Now they do have big ecosystem models, but they use those for stock assessments. They don't use those for assessing the state of the ecosystem. That's an ongoing research effort. So one of the things that you can do is set the right frame, and that can help you figure out how to organize or navigate through all the different sorts of indicators that you might measure. So this was a US EPA effort, a little research project that I was involved in a few years ago called Climate Ready Estuaries. And the idea was they gave these little work groups the job of coming up with these flow charts, and we could only have a certain number of nodes in the flow chart. You couldn't go wild. And then they got a bunch of experts together in a 2-day workshop. We tried to define which pathways through the conceptual model diagrams would be the ones that would be most sensitive to certain specific kinds of climate change impacts. And then we put these symbols on the flow charts. You can see them down at the lower left here. The star is increasing relative impact, and one arrow is increasing sensitivity to climate change, and then the one with the squiggly line in the middle, like down here, that's a threshold effect. And so what it enabled this work group to do in a couple of days was highlight those aspects of the system that were important enough that they could then start designing some management responses to the kinds of likely climate effects. So setting the right framework on the system helps you focus in on what might be the best things to measure and what relationships or processes might be the ones to monitor and manage in response to. So as I mentioned, we'll look very quickly at 4 illustrative examples. And each of them has some slightly different characteristics that make them unique. You'll see that a couple of them, the U.S. Forest Service and the Chesapeake Bay, actually have a very similar structure. And then we'll end up with the San Diego River watershed one, and then Chad Laughlin's going to talk about that in more detail later in this session. So the sediment quality objectives was a state water board effort, and that had a very, very tight focus and a tight question that was to look at and measure and quantify the effects of contaminants on benthic infaunal communities in estuarine environments along the coast. And so because of that very tight focus, they were able to define some very specific sorts of data analyses and relationships and come up with a very well-organized assessment framework that included both measures of exposure and measures of effect, and then integrated into an overall station assessment. And even though the assessment was narrative, it was based on quantitative analyses and quantitative thresholds behind the scenes. So that took a few years. There was a lot of effort involved in defining standardized methods. There was a lot of effort involved in figuring out what the thresholds ought to be, and a ton of effort involved in road testing the narrative assessment and how all the different indicators would be interpreted and how the narrative responses would be interpreted and fine-tuned in terms of what the data were really telling us. So it was a new program, and so even though it was using certain things like sediment toxicity tests that were already in existence, because it was a new program, they could define from scratch how indicators would be interpreted and how they would be used. So they had the luxury of doing that, and I don't think that a lot of times we have that luxury in some of the things that we're doing. So the Chesapeake Bay takes a broader cut at things, and this is a report card that comes out of what they call their IAN, Integration and Application Network, and it looks very polished and integrated. But about 15 or so years ago, Don Bosch asked me to come out to Chesapeake Bay and spend 2 or 3 months out there, and they were trying to get this going. The University of Maryland labs around Chesapeake Bay were all doing their own thing, and every researcher was doing their own thing, and They were a little bit separated from the Chesapeake Bay program, and so they did not have the ability, from their perspective, to harness all that research and all that effort and say things about the bay as a whole, the status of the bay as a whole. And so I spent a few months out there helping them sort of get this sort of mindset in place. And now they have a very sophisticated program with all sorts of online tools. And you notice over on the left is the water quality side, and over on the right is the biotic side, and they integrate, the projector is making the lettering a little fuzzy, but so up here are the grasses and the benthic biotic integrity index and phytoplankton, and over here on the left is dissolved oxygen and water quality and the chemistry stuff, and they combine them into a water quality index and a biotic index separately, and then they average them into an overall index of bay health. So remember that part, water quality, habitat, biotic, separate sort of integrated or aggregated indices that are averaged into an overall index. And some people are really uncomfortable with the idea of taking chemistry and biology and averaging them into one overall number. So it's just a philosophy they have, and they were very focused about picking 3 things on each side, and then working with those. And in the more recent couple of years, they're working on adding some fish abundance indices to this, but they haven't integrated into the overall report card yet. And so what they're able to do with this is look at patterns and trends. They have a coordinated set of indicators because they have some a track record with this. They've worked on it for a number of years. They have integrated regional sampling. They have methods that they've all worked on together that are consistent, and they have really well-defined scoring methods and thresholds and a coordinated management structure that integrates all of these efforts and produces this assessment on a yearly basis. And so, again, just as the Bering Sea, Aleutian Islands report card did, they have a health scale and a trend scale. And so they're able to look at different parts of the bay from different perspectives and see how healthy they are, and then whether they're getting better or worse. And so it's 8 ways of answering at least a couple of the questions that Eric posed at the very beginning. And the U.S. Forest Service does something very similar. They take, over here on the left, they have a aquatic physical, which includes water quality, and they have the biology. And then they have the terrestrial physical and the terrestrial biology. And they integrate each of these separately, so they get 4 scores, and then they integrate them all together in a watershed score. And so the interesting thing about the Forest Service is they do this across huge areas, and so obviously they don't have the kinds of sampling programs that they have in the Chesapeake Bay, and so they vacuum up whatever information is available, including best professional judgment, and they score each hydrologic unit on a 0 to 3 scale for these 12 core indicators and all the 23 attributes. So you see, under water quality, there's 303 delistings and water quality problems that are not listed. So the 303 delistings they get from the State Water Board, for example, but the water quality problems might just be one of their foresters saying, I consistently see a lot of turbidity over here from erosion in this particular sub-watershed, and that'll get scored. And they have a protocol for turning best professional judgment into this 0 to 3 scoring range. So they take everything from observations all the way to whatever monitoring data they might get from other agencies, and they package it up into this framework, and they come up with an overall score for that watershed area, and they can also deconstruct that into scores for individual pieces of it, and they can tell which is at risk and which is highly functioning. And so their intent in doing this is to find out where watershed areas in the ecosystem are functioning well and where they're at risk. And they want to put some attention on the places that are at risk rather than the ones that are degraded. They want to keep the ones that are at risk from moving over into the degraded column. And so this kind of assessment meets their needs. Casts a pretty wide net, and they They can do this because they're doing it the same way that some other programs have done. They just harvest what's in people's heads and then put that out as a report. They don't do a lot of data integration. A lot of the data integration that they do is just on paper and then in spreadsheets. They don't integrate the actual raw data. The San Diego River watershed effort did something similar. They tried to cast as wide a net as possible, and they tried to emphasize the biology as much as possible and then stressors, and not so much chemistry. Just the only chemistry they're looking at is nutrients, conductivity, turbidity, temperature, pH, and pyrethroids. And so you'll see that there's bugs, algae, fish, the USGS invertebrate natives, the U.S. Forest Service watershed assessment, the thing that we just saw. San Diego River program is taking those aggregated scores and plugging them into here because they cover parts of the watershed that the permittee programs and the NGO programs don't cover very well. And then come up with these 4 scores: aquatic biology, biological stressors, habitat-related stressors, and water quality stressors. And then they stop at this red line and don't produce an overall score like the Chesapeake Bay program does. And again, each of these programs, each of these boxes might have 1, 2, or 3 data sources. Some of them don't have any scoring at all. Some have their own well-developed scoring. And so Chad will talk more about how they ended up integrating all of that. So what are the challenges related to going from a really narrow scope to a wider scope? So one of the challenges right off the bat is that there's lots of possible scopes and lots of possible goals. So it's very important, obviously, to figure out what you're trying to do and what questions you're trying to answer, because you can go lots of different places with even a few indicators. And as we get more and more indicators and more measures of process, the pathways that we can follow proliferate logarithmically. And so it's very important to have a really clear vision of where we're going. And the meaning of what integration actually is functionally can get very, very fuzzy. I mean, we can talk about, well, we want an integrated assessment, and all of us sort of nod wisely and go, yeah, that's what we need. And then, well, exactly how are we going to integrate? And then it's like the Tower of Babel, all over again. Everybody has a different idea of what that might mean. And so the process for creating integrated assessment with lots of indicators takes time. That Chesapeake Bay program looks great now, and 15 years ago, they were trying to figure out what they were up to. And so if you look at the history of a lot of these efforts, it takes a fair amount of time. And so it's very challenging to maintain momentum and buy-in as it looks like you're just thrashing around. There's just a lot of thrashing around that's needed to sort of figure this stuff out. And sometimes it looks like you're not going anywhere because there's a lot of stuff that's happening behind the scenes. A lot of times, as we're trying to pull together different pieces, we're dealing with inconsistent spatial and temporal coverage. And so sometimes you can learn something about systems, but if the spatial and temporal coverage of different indicators is different, maybe what you're seeing is really just an artifact of the different designs. Some indicators really only can be measured at really small or really large scales. So when you're trying to match them up or integrate them with indicators that are being measured at different scales, then the statisticians come in and things get really fun. If you don't have the luxury of creating your own design like the SQO program did, if you're trying to do something like the U.S. Forest Service and the San Diego River watershed programs are doing, you really can't go, the San Diego River program can't go to the U.S. Forest Service and say, we need you to do your watershed condition framework differently. They're going to do what they're going to do. And so you need to have tricks up in your tool bag for aggregating or integrating programs that are wedded to the kinds of designs that they've developed for their specific purposes, and you have to respect that. You can't get them to, move just because you want to do some integration. And then, another question is, do we really want to use qualitative data or just quantitative data? There's a lot of really rich knowledge that's embedded in people's heads and in certain kinds of qualitative data, and do we really want to sacrifice that, or do we want to figure out a way to capture that? And that's another real challenge. And the relationships between indicators and between endpoints get more complicated the more of them that we have. You know, Eric showed the problem that people created by making the mistake of measuring a lot of different indicators and comparing the answers they were giving us. So then, you know, if you have that sort of mess, it's a very creative, healthy mess in a way, but if you have that, then you have to start understanding what the relationships are between those indicators and why they're giving us different answers and what it really means. And so, so those kinds of relationships are different. And so the relationships between biological endpoints and things that can be managed are also different. And then there's all the challenges between assessment and scoring and how we do that. And so I just want to close by saying that this all involves trade-offs. And there's a number of different kinds of trade-offs. And so any program is going to sit somewhere on these scales. And so you need to consciously make decisions about what these trade-offs are. I mean, where you're going to sit, not just let them sort of happen to you. And so the more thorough assessments are going to depend on understanding the way systems structure and function, and that the whole is really greater than the sum of the parts. And that really what we're talking about is how to juggle those parts and put them all together. Thanks.
We have time for a few questions. If you're going to ask a question, make sure you use one of the mics. This will be important. Any questions for Brock?
Yeah.
I want to address the rolling up problem as to how far up you roll up.
Yeah.
Just off the cuff, or with an example, what do you think is a sort of an ideal level of rolling up to where you're getting information that's helpful in decision making, but you're not exceeding our ability to aggregate or roll up all of that data?
You know, I think it really depends on the audience. You know, for example, the Sediment Quality Objectives program rolls up 3 different lines of evidence into a narrative result for a site. And so for some other program that was doing a larger sort of watershed assessment in an estuary, that would be a single indicator that would then get rolled up even more. And so I think for certain audiences like public and high-level managers, you might want something like the Chesapeake Bay result, which says the Chesapeake Bay is getting better, and that's what they really need to know. But for people who are actually managing pieces of the system, you want to roll up to something that's appropriate to them. So there's no right answer, sorry. Any other questions? Great, good.